Good afternoon, students. So now we are going to start with the mole fraction. This is also one of the method of expressing the concentration of a solution. Okay. So what is the meaning of mole fraction? It is defined as, suppose if you want to calculate the mole fraction of solute. So you want to calculate mole fraction of solute. It is defined as the ratio of number of moles of a solute to the total number of moles of solute and solvent. Okay. What is mole fraction of a solute? The ratio of number of moles of a solute to the total number of moles of solute and solvent. Now, suppose think that we don't want to use the terms as solute and solvent. Assume that our solution is containing two components, 1 and 2. Okay, our solution is containing two components, 1 and 2. So we want to give a generalized expression for mole fraction. Then how do you define mole fraction? So what is the generalized definition for mole fraction? It is defined as the ratio of number of moles of a component. A component means here you can apply this formula for component 1 or for component 2 also. So the ratio of number of moles of a component to the total number of moles of all the components, to the total number of moles of all the components present in the solution. So what is the meaning of all the components? You can assume a binary solution or you can assume any solution. Let that solution contain any number of components, n number of components. So for that type of solutions also you can frame the statement. So how do you define so in terms of solute and solvent you are having specific definition. But in general if you want to frame a definition for mole fraction, so what is the definition? The ratio of number of moles of a component. Suppose you are having two components. So and if you want to calculate the mole fraction of component 2. So what is this a component indicates? A component indicates the component 2. Or if you want to calculate for component 1, that will be for component 1. Okay. So this is a common statement. The ratio of number of moles of a component to the total number of moles of all the components present in the solution. So first we will take the example of a binary solution. So what is the meaning of binary solution? A solution which contains one solute and one solvent. One solute plus solvent. Now here the mole fraction is denoted by the symbol small x. Now, so if you want to define the mole fraction of solute, so how do you write the expression? It is the number of moles of solute to the total number of moles present in the solution. So n total. Here in this example, what solution we have taken? We have taken a binary solution. Binary solution means solute and solvent. One solute plus solvent we are having. So what is your n total? N total is nothing but number of moles of solute plus number of moles of solvent. What is your n total? It's nothing but number of moles of solute plus number of moles of solvent. So here you can write n of solute by n of solute plus n of solvent. Now, similarly, if you want to Calculate for solvent, mole fraction of solvent. How do you define the mole fraction of solvent? So, number of moles of solvent, it is the ratio of number of moles of solvent to the number of moles of solute plus number of moles of solvent. Okay, so this is the mole fraction. Now, what should be the total mole fraction? X total. Here, our solution is a binary solution and we have two components, solute and solvent. Okay, so what is the X of solute here? Total mole fraction is how much? Mole fraction of solute plus mole fraction of solvent. Right? In this case, suppose we are taking n number of components are there. So what is the X total in that condition? This X total will be the sum of n number of moles. Let the solution contain any number of components. But the X total, what is X total? It is the X of all the components present. Now remember, always the X total should be equals to 1. Let the solution contain two components or more than two components. But it should be equal to 1. Okay, it should not be greater than 1. It should be equal to 1 or less than 1. So this is about mole fraction. So what is mole fraction? It's nothing but the ratio of number of moles of a component to the total number of moles of all the components present in the solution. Now, so what example we are taking? We are taking the example of a binary solution. So what is a binary solution? A solution which contains one solute and solvent. Now, so how do you determine the mole fraction of the solute? It is the ratio of number of moles of solute to the total number of moles of the solution. So total how many components we are having? Two components, solute and solvent. So what is your N total? So your N total is nothing but it is the number of moles of solute plus number of moles of solvent. Then so substitute this value N total, N of solute by N of solute plus N of solvent. Then what is the mole fraction of the solvent? It is the number of moles of solvent by number of moles of solute plus number of moles of solvent. Now what is X total? X total is what? The number of moles of solute plus number of moles of solvent. Always the X total should be equals to 1. Or it can be less than 1 but it should not be greater than 1. Always X total should be equal to 1 or it can be less than 1 but should not be greater than 1. So let the solution contain n number of components but the total mole fraction should be equals to 1 or less than 1.